Alright everybody, this video has sound, so hopefully everyone is hearing my voice, or at least watching me point at this sign and getting the sound up and going on their video. Alright, this is a lesson on 10.2. It's called a prerequisite skill. It's a skill that you need to know to be able to do chapter 11, but we don't cover all of chapter 10, but this particular skill, section 10.2, is important to be able to do chapter 11. So we're just going to go back and grab this one skill from chapter 10 out of the prerequisite skill 10.2 supplement. We are going to be quizzing on this, so you do need to know this. All right. What is an arc? Well, an arc is part of a circle. So if I draw a circle and I draw something called a central angle. A central angle is an angle where the vertex is touching the center of a circle. Or is positioned at the center of the circle. An arc is essentially this distance here, which can be measured in two ways. You can measure this as a degree of angle from this side over to this side, right? So I could measure that as maybe, 87 degrees. That is called the arc measure. Measures are measures of angles. Now, there's something else about an arc that we can measure, and that is the arc length. An arc length would be if you took out a little ruler or a tape measure and you measured the distance from here over to here on the outside of the circle. It's a measure of part of the circumference of the circle. Circumference is the distance around the outside. As you can see, this is just part of that. So if I measured that right now, it might be 3 centimeters. Okay, so that is called the length of the arc. Okay, so you can see that's two very different things. An arc measure is a measure of the interior angle here, the central angle in the circle. And the arc length is the measure of that outer edge of the circle that the angle kind of defines. Okay, so on this lesson, we're going to be talking strictly about arc measures. So we're going to be talking about angle amounts. And then in the next lesson, lesson 11.4, we're going to be talking about arc lengths, and then a little bit more about arc measure. Okay, so it's a very important distinction. A minor arc is less than half of a circle. So mine is a minor arc because it's less than half. And a major arc is more than half. So if I measured, for example, from here all the way over to there, this is a major arc. Semicircle is exactly half of a circle. And as I talked about before, the measure of a minor arc, since it's less than half the circle, would be less than 180 degrees. Measure of a major arc would be more than 180 degrees. Congruent circles are circles where they have the same, exactly the same size, and very importantly, exactly the same radius measures. Congruent arcs are arcs where the central angles match, and the circles that they're in are exactly the same size and shape. Okay, so now we have a little bit of an idea of what arcs are. You can measure the length of the arc by measuring the outside edge of the circle from one side of the angle to the other, or you can find the measure of the arc by finding the actual angle inside. Alright, now measuring arcs down here is just a little cheat sheet here. Here you can see we have a minor arc right there, because this little section is less than half a circle. And then from here, if I go around all the way to there, that distance would be a major arc because it's more than half a circle. Obviously, the measure of the entire circle all the way around is 360 degrees. We've learned that previous in math. And the measure of the major arc is the difference between 360 and the measure of the minor arc. So basically what they're saying is these two should add up to be 360 if you add this number of degrees plus that number of degrees, and sure enough, 50 plus 310 is 360. A half a circle is 180 degrees. Probably already knew that too. Now, remember up here how I told you there's a difference between the measure of an arc and the length of the arc? Well, the measure of the arc is written like this, with a little m in front of it. You see that? When you see the m, they're talking about the measure of the arc, which is a measure of angle. Okay? Now, the length of the arc will not be written with the m in front. The length of the arc will have no m. Okay, so let's do some, let's do this. I'll see now that that doesn't have an M in front, but now I'm a little confused as to why they wouldn't put the little M's in front. So let's go ahead and put those measures in there. You can see that it's written correctly the rest of the page, but okay, so the measure of arc DE. Well, DE, they've marked that as 117 degrees, right there. What is the measure of arc DFE, or D? Oh, now DFE means that you start at D, and you go around the outside of the circle past F, and then end at E. Now, if I went this way, that wouldn't make sense, right? So if I had to do a trip around the outside of the circle, and I had to start at D, go past F, and end at E, what would that path look like? Well, if I started at D, and went this way, I would go past F and I would end at E, right? So that would be this distance from here to here. So how many degrees is that? Well, if the entire circle is 360 and this part that I'm not covering is 117, I should easily be able to find that by taking 360 minus 117, which gets me 243. So that is the measure of the arc from D around to C to E going past E. Or sorry, from D around to E going past F. Okay, now this one is asking for the length of the arc from D going past E and ending at F. So you start at D, you pass E, and then you end at F. So starting at D, going past E, ending at F would start here, and it would go around the circle over to here. Starting at D, going past E, ending at F. Well, that's half a circle, right? Because this line is straight to me, so half a circle is 180 degrees. All right. What's the measure of arc RTS? So remember, that means it starts at R, it passes T on its way, and ends up at S. So R past T, ending at S, would start here, go around the circle this way, and end right there. So they want to know the measure of that major arc. Well, it's almost a whole circle except for 45 degrees. So if I take 360 and I subtract 45 degrees, I can calculate the measure of that arc to be 315 degrees. The arc addition postulate says that if you have two arcs that are next to each other, that the arc formed by those two can simply be found by adding the two parts together. So basically, they're saying that if you take this section here from A to B and measure that in degrees, and then take this section here from B to C and measure that in degrees, that you can find the distance all the way from A to C by simply adding these two pieces together. So the measure of AB plus the measure of BC, so again this section plus this section, should equal the measure from A past B all the way to C. If you join a new bank and divide your money in several ways, as shown in the circle graph at right, let's find indicated arc measures. So this is 55, this is 105, this is 60, and this is 140. When you add all four of those sections together, you do get 360 degrees. So let's see, the measure of arc B going past C and ending at D, right? Because you start at B, you go past C, and then you end at D. So B, C, D would basically be these two sections together. So if I add 140 degrees plus 60 degrees, I get 200 degrees. If I want to find BCA, wow, that's a long one. So starting at B, going past C, and ending at A. That would be these three sections here. So 140 plus 60 plus 105 gives me a total length of 305. For BCA. And then starting at A, going past B, and ending at C, ABC would be this section here, which would basically be the 55-degree section for checking, and then the 140-degree section for money markets. So I would add 55 plus 140, which gives me 195 degrees. All right, and then the last page. Tell whether the given arcs are congruent and explain why or why not. Well, congruent arcs have to have the same measure, and they have to come from circles that are the same size. So as you can see here, arc BC is 75 degrees, arc DE is 75 degrees, and they're on the exact same circle. So I would say yes, both are 75 degrees and on the same circle. Those are the two qualifying characteristics for congruent arcs. Okay, so how about AB and CD? Well, I'd have to say no. They are both 80 degrees, but they are not on the same circle, or the same size circle, I should say. So even though they're both 80-degree arcs, it doesn't work. They're not congruent arcs. And then FG and HJ. Are they coming from the same size circle? Well, it turns out yes, they are, because this circle here has a radius that's marked the same as the radius of that circle, which means they have to be the same size. And since their measure is both 90 degrees, then that would be a yes. Both are 90 degrees and are on the same size circle. So is PQ congruent to SR? Well, again, I would say yes. They are marked congruent in measure and they are on the same circle.